Welcome to EPG Pathshala, the lecture series for postgraduate students. This is the module for the MArch students in architecture. The paper we are discussing is Sustainable and Green Building Design, and the topic we'll be delving into is building environmental ethics. So in this lecture, our main objective is to first define what exactly is sustainable design. Then we go on to understand the importance of sustainable design in today's context, especially in the context of the Indian scenario. Then we go about to understand the role of a building in a sustainable environment and what role they play in today's environment of sustainability to realize the inclusive nature of sustainable design. What exactly is sustainable design and how do we go about building a particular environmental ethic around it? So when you talk about building an environmental ethic, we can never separate the site away from the building. So always how our aim should be, how can architecture or any example of architecture live lightly on the earth? We should try to create as much as less burden as possible on the earth as possible, rather than extracting as much as energy as in the context and giving very less in return. So our main environmental ethics should be building along to the site, keeping the site in mind and having the building as a lightly placed object on the site rather than a deeply embedded object which has no context whatsoever to that particular environment. Now, right now in this example that we see here, this is the Aldo Leopold Legacy Center in Wisconsin. This is considered a carbon neutral building and was graded a LEED Platinum. When you look at the site and the correlation to the building, it is very much in cohesion, it is very much in harmony. It is not a glaring glass facade and a metal structure. The materials and the environment and the site all go hand in hand. And that is the beginning of developing an environmental ethic. So what is environmental design? What has happened in today's context is we have something that is emergent, is corporate architecture. According to Lewis Mumford right here, a modern architect has produced the most flagrantly uneconomic and uncomfortable buildings which can be inhabited only with the aid of most expensive devices of heating as well as refrigeration. The irrationality of the system of construction is visible today in every city from New York to San Francisco. Glass sheath buildings without any contact with fresh air, sunlight or view. This happened in the West, in the United States and Europe much earlier than it has struck the eastern countries like India. What exactly has happened is a particular frame has been created where a building has to fit in. We have forgotten the importance of site, climate and other such factors that go in an architecture. We have related posh and expensive sort of living as the primary way to live. We have forgotten that there is something called climate responsive architecture, there is something called sustainable design. Now what has come to the current scenario is we have created a problem over the past few decades and now we are striving hard to find a solution. Till now, India and other countries of the East have always aped the West. We have always tried to see urban renewal, let it be any form of architecture. We have always tried to see what they have done and follow it up in their footsteps. And now when sustainability is the mainly talked about topic in countries like United States and Europe, this is also the right time to actually look at them and decide that certain things that we have taken from them is not apt for our country, our climate and our energy scenario. If you look at environmentally sensitive design, it actually has to be harmonious. It has to be responsive to climate. We have to make sure that our consumption of energy in terms of heating the building or cooling the building is minimal or negligent for that matter. So let's try using natural air, natural light, natural ventilation, natural solar characteristics so that we can minimize the consumption of energy, as well as the building that is there seems to be a part of the site rather than something that's been forced upon it. So we have to make sure our dependency on renewable resources is very, very minimal. and the non-renewable resources should also be considered for and made sure that the building is giving back at the rate it is consuming. So basically, sustainable building design looks to live lightly on the earth, so there will be quality as well as resources for the generations to come. The project over here we have is the Eden project in United Kingdom, where it's incorporating nature as well as innovative architectural design. This again was a very controversial topic because in spite of it being a passive design in terms of environmental design where the consumption was nil, the energy consumption was nil, the way took from the earth was very less, but the material that was used was not considered to be the primary utility because it changed the value of the building tremendously, and this building definitely does not look as if it belongs to this site. It does look as it's been thrust upon. So here again there are two different ways of thought. Can a design be completely passively designed with less energy consumption? At the same time, can it be flagrantly designed in terms of design? So does all climate responsive architecture buildings cannot have a cool factor? Is that true? Not really, and the Eden project is one such example where the architect did play around with spaces, materials and all of that, but still it proved to be a good example of a carbon neutral building. The ethic behind sustainability. Now coming to an example within our very own country, this is the Sembra Valley in Kodaikanal. This is a resort that was developed, and this place is created, submerged and surrounded by nature like you can see over here. The rooms are pretty much in context with the site. They are not thrust upon it, and any cutting along the hills that has happened in cohesion with the trees that were there. And it was very much decided that any trees that were cut down during construction were accounted for and replaced as an afforestation program side by side. So sustainable building actually is not a new genre of architecture. Like how we have modernistic architecture, Art Deco movement, all those are styles of architecture. But sustainable building is a basic requirement of architecture. Like how we have light, ventilation, and we have basic materials that are required to build a building, sustainable design is one such basic requirement that needs to be considered. It is not an option for an architect to follow, but it is a requirement for every architect to follow. So our primary goal is to lessen the harm any poorly designed building can cause by using the best of ancient building approaches, but with a logical combination with the new technological advances. I think this is the best time to learn from history. If you look at any of our old historic buildings, all of them are considered the best examples of climate responsive architecture. How many palaces and forts have been there for centuries? And do they require fans, air conditioning, and still they are very good places to live in. Even when you visit these places as tourists, you can see there's a drastic temperature difference of about 5 to 6 degrees from the concrete jungle that we live in. And the main reason for that is the style of design, the materials behind the design, and the site location. And that is what we need to learn from ancient practices. But that doesn't mean we cannot have the creature comforts. We do need to retrofit these buildings and make sure we adapt the new technological advances to them so that we have the best of both worlds. This is another example of the Sembra Valley part. This is another portion of it where you can see that you do have elements of the modern era. You have the traditional paving. You do not want to have a completely muddy route and all of that. But the way it has been done is the lights are completely solar powered. It takes power throughout the day from the sunlight that is there, and once the sun sets, it automatically triggers on. But the problem with this is it's not completely foolproof. The days that are very cloudy or rainy, it does need an external boost of energy or electricity. But we need to have a fallback plan. A plan B is sufficient enough for the current scenario we are in. Rather than taking energy on all days when the sun is capable of giving us energy, on the certain days when it is gloomy or cloudy, we can step in and substantiate for that. But the main ultimate goal is to make offices, homes, and as well as entire regions that are net producers of energy, clean water, air, healthy human life as well as biological communities. So that is the root of all ethics of sustainability. We need to ensure that these become the basic necessities have now gradually become luxuries. We actually have people selling air from New Zealand, Canada to parts of Beijing and Shanghai because the air has become so polluted. So something that we have been taken for granted is now become a luxury item. When did clean air and water become a luxury item rather than a basic necessity? All this is the roots of sustainable ethics. So our aim here is to try to make greener buildings such that they take less and less from the earth and give more to the people and the users of the building. If you go about defining the ways of sustainable design, it's basically a development where we try to make the needs of the present without compromising the future generations, such that yes, we do need coal, we do need electricity, but we need to keep a check on our consumption and make sure there is enough for the future generations. And at the same time, we need to envision the prosperity of all living things throughout the globe and just not of one country or one region. Sustainable design seeks to create communities, buildings, products that contribute to this particular vision. If you look at David Orr's definition of sustainability, he defines sustainable design as a careful meshing of human purposes with the larger patterns and flows of the natural world. So if you look at the key words in this, human purposes is not ignored because we are the final users. We have to keep the larger patterns, that is the bigger picture in mind, as well as the flows of the natural world. We cannot intervene with extra plastic resources to support our life. Let's make sure our usability is within the realms of nature and not detract too much away from it. This is an example of the Lavasa Hill Town spread that has been commissioned near Mumbai and Pune region. This is the emerging science of biomimicry, and this is been designed over a span of 12,500 hectares, and the completion date of this is 2020. It's well en route to getting done. A lot of the plans behind this is from sustainable design, where they want to prove that an entire town can be built such that it is completely sustainable, it is green, the individual buildings are green, and the entire town is green such that the carbon emissions are much lesser, the carbon footprint is much lesser, and the design is nowhere in compromise to the architectural caliber. If you look at the Lavasa, the credentials are right about here. You have 70% amount of previously deforested land is going to be restored with detailed landscaping, reforestation and slope greening. So any project in the hill stations, that is one of the final primary goals of sustainable design. Any tree or any plant or group of plants that are removed, first, the point to be noted is they are not indigenous species. If they are indigenous species, they are best avoided to be removed. If at all it has to be removed, they are replanted or transplanted, or new percentage of greenery replaces the ones that have to be removed. There is a 30% reduction in carbon emissions. There is a 65% reduction in potable water consumption and a 95% reduction of waste sent to landfill. So all of these, if it happens by 2020, will set a great example within our own country that it's possible to actually have a town with great number of inhabitants and have a sustainable way of life. So here in Lavasa, if you see, the biologists have been actively involved because biomimicry was one of the main things they wanted to incorporate in this design, where living creatures and plants of the moist deciduous family or ecosystem were to provide guidance and the models for establishing locally attuned design strategies that actually respond to the challenges of the local biome. So what happens over here is Lavasa's heritage was stuck to Lavasa. The site of Lavasa was not compared to something that was there in Europe or United States. So the indigenous species, all of that was compared with respect to Lavasa, and a design proposal for this particular site emerged not relating to any other site elsewhere. So it is completely indigenous species, local species, and a very suitable example for us to follow. If you just see the energy consumption in India, in North America, if you look at the energy consumption in North America, the buildings consume a whopping 48% as compared to an industrial consumption of only 25% and transportation only a mere 27%. When I say buildings consume 48%, it is a huge percentages because of heating, cooling, elevators, because when you have skyscrapers, elevators, and you have something called high-speed elevators and normal speed elevators. All of these services play a huge role, and all of these services require a huge chunk of energy, and therefore the whopping 48%. Now if you come to India, within India, buildings are not far behind. We are at close to 30% of energy consumption by buildings. If you look at a completely developed country like North America and compare it to India, I think we are way ahead than where we should be, because we have a rapid rate of growth in the recent past, and this has resulted in a huge energy deficit. So you have increasing number of industries, commercial complexes, residential units, gated communities, agricultural facilities, and all of these require captive power generation. So basically they need generators. If they do not need generators, they need electricity. So diesel generators have been the single largest source of captive power, also the single largest source of greenhouse gases. Even the so-called resorts that are sustainable green resorts that are emerging across all these hill stations, they are far away from all electricity grids, and they are completely dependent on diesel generators. And because they use diesel generators, the green quotient of the resort drops down by a huge percentage. Just by using adobe or mud bricks or exposed brickwork, it doesn't mean the building is green. What kind of energy does it consume? What kind of energy does it give back to the earth is what decides how green a building is. This is an example of a net zero energy building which is located in Bhopal in Madhya Pradesh. How actually organizations can go beyond the role by adopting the best in energy conservation technologies. They can actually even augment energy supply by implementing these green energy systems and leverage nature's abundance of solar energy. A net zero energy building is a highly energy efficient and produces at least as much as energy over the course of year as it consumes. So that is the huge factor. So in a year, if a building is consuming say X megawatts and it's able to reproduce that replenish that within the following year, imagine the energy capacity of our country that it would be. So this is something we need to look at. Though the initial investment is quite high, the returns are much higher and greater. So if you look at the demand side renewable building technologies, Sun Carrier Omega is one such company which includes daylighting, insulation, occupancy monitoring. Occupancy monitoring is nothing but when a room or a building has a capacity of 20, the air conditioning and the everything energy that building consumes will automatically shut down for the requirement of 20 people. Say there's an event that is occurring and the capacity increases to 150 or 200, automatically that would kick in. So there is a better efficiency in terms of using the machinery, as well as the comfort level is also maintained. High efficiency HVAC, natural ventilation, water harvesting and evaporative cooling. We do have to note that Bhopal is one of the hottest cities in the country, and if they can do it, then many other cities across the country can do it as well. So we need to create grid independent habitats. Grid independent habitats are essentially buildings or gatherings of buildings that are no longer dependent on the electricity grid. They create their own power and they are able to distribute it within amongst themselves. So pollution is an act of design. So anything man designs is basically keeping a date of expiry in mind. Even our buildings these days are keeping a date of expiry. If it's a concrete structure, if it's an apartment, we give it 75 years. If it's something else, 25 years, 50 years. So we are the only people that we come up with a date of expiry even before something is in the manufacturing process. So even this building was basically designed to be basically thrown out. You can see the energy waste and energy consumption that was there when we built this building, while demolition and while replacing, and the huge energy resources that it's actually consuming. So basically, we are the only race that consumes things without any regard for where it actually goes. And even if we throw something in the garbage, we don't know where it goes from our garbage can. We don't think of the landfill. Let it be right from food to building materials. Everything is the same. So shall we actually go about designing for disassembly so that even buildings can be taken apart or repaired or reutilized, and by which we can even dismantle them and keep them if they are no longer in use? Is that possible if we think of prefabricating certain elements or certain elements of the building? Reuse actually means less energy than recycling. Recycling also requires a lot of energy because we are first bringing it back to scrap and then recreating something out of that scrap. So there is a lot of energy used even in that process. But if you're going to reuse something with a small retrofit here and there, it's a much better option. This is something that we really need to face. Buildings are responsible for around 40 to 70% of world carbon emissions, and that's a very high percentage because buildings is something that we can never do away with, and as architects, buildings are our bread and butter. If we cannot design a building, what is it that we'll be doing? But as architects, it is our responsibility to design buildings such that they do not detract from this fact, but actually add on and say that our building is contributing to a greener society and a greener place. So what are the basic problems that we would basically face? No power, hot weathers in summer or cooler temperatures in monsoon and winter. If you look at India as such, we have regions that are majoritarily hot and humid or hot and dry. North and certain parts of the south where hill stations and all of those are there, we have cooler temperatures and a temperate climate where there's a drop in temperature between the day and night time. So we are dependent on electricity, heating and air conditioning. So what exactly how do these environments work? How do these built systems and buildings work? And what is it that these buildings that we are currently designing, in what way do they not work with respect to the environment? Now, even if you go to all of these eco resorts and everything, one of the first options they give is air-conditioned rooms and non-air conditioned rooms. It could be a place like Ooty, Kodaikanal, like we saw in Sembra Valley, but there's still a requirement is an air conditioning requirement, because to get a star rating, air conditioning is compulsory. So we need to rethink a lot of these facts and scenarios, that what decides a rating of a hotel, what decides the comfort level of a hotel. Our comfort level is not dependent on whether the air conditioner is running, but it should be dependent on how well the building is responding to the climate outside and how well it's protecting you from it. If you look at all these, if you look at the skyline and the image over here, these are all sealed buildings which basically cannot breathe. These are all fixed windows except for the emergency window in emergencies like fire. Elevators and lights need power. Modern architecture really does not work. This has become an equivalent of what every city skyline wants to look like. It is no more a city has any individual identity. Now, this could be a skyline of any city. It could be Bombay, it could be New York, it could be San Francisco, any of these cities, because these buildings truly have no identity. So even as architects and as professionals who deal with design day in and day out, this is not something we should go for. Sustainability is a huge factor, yes, but even as a design factor, what is so great about these buildings? They are just replicas of the buildings that were built when there was these technological breakthroughs like elevators, materials like steel and glass. So they wanted to build these buildings to showcase these materials. Now I think we have come away from that phase and fad, and we need to face up to the truth and design for the current scenario. We need to really awaken to certain facts. Grid and energy dependent buildings and environment and such systems really do not work. We need to have operable windows, not fixed windows and glazing. Natural ventilation is any day great. Natural shading devices are better. Sunlight definitely helps, where we can utilize the energy from the sun as well as daylighting. Wherever required, we can daylight the spaces and not use artificial light. Walkable neighborhoods have definitely worked, where we can actually reduce the consumption of fuel, and bicycles and walking rather than taking a motorized vehicle for even the shortest distance. We should actually begin to design our buildings and environment in reverse, which means first unplug the building, let's just think of the environment, and then start designing the building, rather than having a great design of a building and just thrusting it on wherever our site comes up. First, we will only keep the sun in mind as the primary source, cool only with using natural devices like wind and shade, and transferring this with things like stack effect. Use only light during the daylight during the day, and architecture should come first, then comes the mechanical systems. Now, any architect gets a design project, his element is very small. Then he gives it to the HVAC guy, then he gives it to the fire department. So there are a lot other inputs. So let's reduce the mechanical systems to the maximum and make sure there's a renewable energy before hooking up to natural gas or regular electrical grid. So passive design is where building uses the sun, wind and light to heat, cool and light architecturally. We need to make a radical realization that the current lifestyle that we have adopted from the West with respect to our consumption of energy or any of the natural resources is definitely not a sustainable way of life. Developing countries like ours, with much higher population, are striving to ape the North American lifestyle, including architecture, which again is not a very good solution. If you actually look at the carbon dioxide production by country in the year 1997, which is nearly like 20 years back, we can actually see that China is about 0.75 tons of carbon per capita, and United States was 5.48. And if you look at India, India was a meager 0.29. Now, if you fast forward to 2011, you can see India has come to 6%, China is a whopping 28%, and United States has actually dropped to 16%. So if you look at the million tons of carbon consumption from 1950 to 2012, India has risen drastically from the year 2000 to the current scenario. China from year 2000 to the current scenario has been a very steep climb. United States has been always on the higher end, but it has not suddenly increased at any point of time. So this is something we need to take into consideration. And here again, this is in United States, of course, the buildings consume a whopping 76%. So when buildings are consuming so much energy, who has to be held responsible? It is the architects, because the architects are the ones who are designing the buildings that are proving to be energy guzzlers. They consume energy constantly throughout the day as well as the night. If you look at a comparative analysis between residential buildings and commercial buildings within our country, these are the statistics from India. You can see within residential buildings, fans take about 34%, lighting 28%. In a country like India, most cities are well lit by the sun. We should be maximizing the use of daylight rather than depending on light fixtures and electricity. Then we have refrigeration and air conditioners take about 20% together, television and others about 14%. Now, if you look at commercial buildings, you can obviously see a very sad scenario here where we are depending on lighting for just 60%, HVAC or air conditioning for 32%, and others is about 8%. So when we actually think of consuming so much of energy because of lighting, it is obvious that we are having certain design flaws, because we should be able to maximize the use of daylight and ensure that Most offices run only throughout the day. Assuming that even there is a night shift, it's only then that electricity consumption for lights should be there. So if the building is well designed and well ventilated, this scenario should drastically change. So let's look at the checklist that we have. We need to definitely treat the earth well. It is not our birthright to consume whatever we earn. Rather, it is our duty to make sure that this earth is given to our children and future generations in an intact manner. A sustainable building should make appropriate use of the land. It needs to protect agricultural, cultural, and archaeological resources. It has to be a place where people are happy to live in. It needs to be economical to build as well as operate. So how do we go about answering this challenge? Architects, we need to figure out how to solve this problem by designing buildings more sustainably and holistically. Also to use less and less fossil-based fuels, as we will not be in a situation in the future where we can completely rely on them. So we have to be making sure that we are more self-reliant and make sure we are using resources from sun, wind and water rather than, and when I say water I mean for electricity, because we need to have a renewable source of electricity rather than coal and other fossilized fuels. For us to have a sustainable life and a sustainable living, it starts from the building, but it ends with the way of life the user is going to use that building. So that brings us to the end of this module. Thank you.